In electrostatics, especially we have to discuss about electric charges and fields. Electric charges and fields. So this total electrostatics is a part of electromagnetism. This electromagnetism can be divided into the first one is electrostatics and the next one is electrostatics means it is charges at rest. So what is electrostatics means? The study of charges at rest is called electrostatics. So in this session we have to discuss about electric charges and fields, electric charges and fields and potential and capacitance. So that is about electrostatics. In this we have to study about electric field. And next one is electrodynamics. So in this we have to discuss about a magnetic field. Electrodynamics means charges moving with a uniform velocity. Uniform velocity. In this branch, we have to study about current electricity, magnetism, electromagnetic induction, alternating current. So all these concepts belongs to electrodynamics. In this, we have to study about magnetic field. In electrostatics, we have to study about electric field. And the next one is electrostatic means statics means charges at rest. Electrodynamics means charges moving with a uniform velocity or constant velocity. And one more branch is charges when charges are accelerated. When charges are accelerated. So in this we have to study about electromagnetic field. So in which we discussed about both electric field and magnetic field. So it is nothing but electromagnetic waves. So in that electromagnetic waves, we have to study about the visible spectrum, infrared region, microwaves, radio waves, ultraviolet rays, X-rays, gamma rays. So here in this, we study about both electric fields and magnetic fields. Okay. So electrostatics means charges at rest, electric charges and fields, potential and capacitance we have to study. And in this, we focus on electric field only. When charges are moving uniform velocity, that is belongs to electrodynamics, in which we have to discuss about the current electricity, magnetism, electromagnetic induction, alternating current, and one more is charges are accelerated. When charges are accelerated, in that we have to discuss about electromagnetic waves. So this is about the introduction. And next one is the first primary discussion is charge. What is charge? How many types of charges are there? And properties of charge we have to discuss. The first one is charge. What is charge? The property of your body by the virtue of which it is produces as well as experiences the electric and magnetic field is called charge. So charge means it is the property of your body by the virtue of which it can produces as well as experiences the electric and magnetic field is called a charge. So, which is able to produce as well as experiences both electric and magnetic fields is known as charge. It is the fundamental property. It is the fundamental property. And the next one is types of charges. So all we know that there are two charges. One is positively charged bodies or positive charge, and the next one is negative charge. If we can take any substance, we know that it is made up of atoms. If we focus our attention on atom, and in that atom, protons and neutrons are inside the nucleus, and electrons are revolving around the nucleus in different orbits. So positive charge means, so it is now the body consists of protons and neutrons. So it is neutral body. It is neutral body means it have same number of protons as well as the same number of electrons. So positive charge means it is deficiency of electrons. If we can take in some electrons from this body, if we can take in some electrons from this body, then it becomes a positively charged body. Means it has deficit of electrons. So how can we define positive charge? The deficiency of electrons can produce positive charge. And what is negative charge? If we can give some electrons to this body, then it becomes negatively charged body. Means excess of electrons. Excess of electrons makes negative charge. Deficiency of electrons makes positive charge. So we have basically two types of charges. One is positive charge, another one is negative charge. Positive charge means the deficiency of electrons is known as positive charge, and excess of electrons is known as negative charge. Okay, and we know that the charge of a proton or electron, it is 1.6 into 10 to the power of minus 19 coulombs. We know that the unit of charge is coulomb. What is the SI unit of charge? Coulomb. And the numerical value of charge of electron or proton is 1.6 into 10 to the power of minus 19 coulombs. If it is electron, then it is minus 1.6 into 10 to the power of minus 19 coulombs, and if it is proton, then it is plus 1.6 into 10 to the power of minus 19 coulombs. Is it clear, Anshita?
Yes, sir.
We know that charges are two types. One is positive charge, and another one is negative charge. So positive, negative. These are known as positive, negative. These are known as what charges? Like charges. Positive, positive. These two are known as what?
Ripple.
Unlike charges. So like charges means positive, negative. These two are known as like charges. Like charges repel each other. Unlike charges means positive, negative, or negative, positive. These are known as unlike charges. Unlike charges attract each other. Okay, like charges repel each other. Unlike charges attract each other. Electrification. So what is electrification? The process of converting a body into a charged body. The process of converting a body into a charged body is called electrification. So there are three methods to electrify a neutral body. Okay. So now we have to discuss about electrification. What is electrification means? The process of converting a neutral body into a charged body is called electrification. So here we have three methods to electrify a body. So how many methods are there to electrify a body? We have three methods. The first one is electrification by friction. And the second one is by conduction, and the third one is by induction. So we can electrify a body by using these three methods. The first one is electrification by friction. Second one is electrification by conduction. And what is third one? Electrification by induction. So friction means it is nothing but we can rub two suitable bodies, one against the another. If we can rub a glass rod with a silk cloth. Okay. If we can rub a glass rod with a silk cloth. Now, if it is a glass rod and it is a one silk cloth. Initially, these two are neutral bodies. Means the number of protons and number of electrons inside the glass rod and the number of protons, number of electrons in the silk cloth, both are equal. Now, if we can rub that glass rod with a silk cloth, what happens? Sum of electrons from glass rod are transferred into silk cloth. Sum of electrons from glass rod are transferred into silk cloth. Means here there is a deficiency of electrons in the case of glass rod. That's why it becomes positively charged body. And it can acquire electrons, excess number of electrons. So it becomes a negatively charged body. Means we can convert these two neutral bodies into charged bodies by friction. So this process is known as what? Electrification. Okay. And we know that if we can comb our dry hair by using a comb several times, if we can keep pieces of papers inside near the comb, what happens? The pieces of paper are get attracted by the comb. So that is also due to electrification. Means the comb acquires a charge. That's why it can attract pieces of papers. Okay. This is known as friction. Friction means it is nothing but we can rub two suitable bodies. Okay. Both are initially neutral and we can convert them into charged bodies. So this is about friction. And the next one is conduction. Conduction means if we can take one charged body, so for example, it is a negatively charged body and one neutral body or chargeless body. If we can keep contact these two bodies, okay, then what happens? Sum of electrons from this body is transferred into another body which is in contact with the first body. For example, if it is the body A and it is the body B, A is a charged body and B is a neutral body. Now we can keep contact the two bodies A and B. Then what happens? Sum of electrons from A are transferred into B. Means in B body there is excess of electrons. The charges which are inside A, those are transferred into B. Means, for example, it is a negatively charged body, then it is also becomes a negatively charged body. Okay. So this process, by keeping contact with two bodies, we can convert one neutral body into a similar charged body. This process is known as conduction. Since these two are both have the same charges, so after conduction, both of the bodies are repel each other. So here one point is that conduction precedes repulsion. Means after conduction, both the bodies are repel each other. So this process of conversion of a neutral body into a charged body is known as conduction. And one more is induction. Induction means it is also similar to the conduction, but in induction there is no contact between the two bodies. And the next one is induction. If you can take one glass rod, so this glass rod is positively charged body. Okay, this glass rod is a positively charged body. Now we can take one neutral body like this. So it should have both positive charges and negative charges. Equal number of positive charges and equal number of negative charges. When these two bodies are in sufficient distance, then what happens? So all the negative charges are comes near to the glass rod, and all the positive charges are move away from the glass rod. Means in this neutral body, all the negative charges are get attracted by this glass rod, and all the positive charges are repelled by this glass rod. So one side is acquires negative charge and another side is acquires positive charge. Now, if we can connect this body into ground, then what happens? Some electrons are transferred into this body. We know that Earth is a very good conductor and it is a great source of charges. So, when we connect this body into Earth, some of electrons are transferred into this body. So, all these positive charges get neutralized by the electrons which are coming from Earth. So only what charges remains finally? Negative charges remains finally. So this process of converting a neutral body into a charged body is called electrification by induction. So in this induction, if both the bodies are at sufficient distance, since it have the positive charge and it have the negative charge, means these two are unlike charges. So unlike charges attract each other. So induction is precedes attraction. Okay. Conduction precedes repulsion and induction precedes attraction. So this is about the process of electrification in the method of induction. Now we have to discuss about some properties of charges. Properties of charge. In that we already discussed about that. What unlike charges attract each other and like charges repel each other. So this is the first point. Means positive positive repel, positive negative attract. So that is the first point. And the second one is the smallest possible charge. Smallest possible charge is charge of electron. What is the smallest possible charge? The smallest possible charge is charge of electron. And here we have two types of charges. One is positive charge and another one is negative charge. The charge of proton or electron is nothing but 1.6 into 10 to the power of minus 19 coulombs. So here we have to remember one point, that is SI unit of charge is what? Coulomb. And we know that the mass of proton. What is the mass of proton? It is 1.67 into 10 to the power of minus 27 kilograms. And the mass of electron equals to 9.1 into 10 to the power of minus 31 kilograms. And next one is charge is quantized. So what is the meaning of this quantization of charge? Quantization means if we want to transfer charge from one body to another body, then the charge is flowing from one body to another body in the form of number of electrons. Means here one body is there, here one body is there. Then it is possible to transfer one electron or two electrons or three electrons or four electrons from one body to another body. But it is not possible to transfer half of electron or one third of electron or 2e by 3. Means this type of transformation of charge from one body to another body is not possible. If we want to transfer electrons from one body to another body, then it is the only way, that is we can send electrons integral multiple of electron, means one electron or two electrons or three electrons. That is total charge is quantized, means it can be written as Q equals to plus or minus Ne, where N equals to 1, 2, 3, so on. So this is known as quantization of charge. Quantization means nothing but if we want to transfer charge, then it is only possible in multiples of electron, means one electron, two electron, three electron or four electron. But it is not possible to transfer half of electron or one third of electron. That property is known as a quantization of charge. And the next one is, for an isolated system, the charge is conserved. Conserved means the charge neither can be created nor destroyed. Okay. Conservation means, for example, if one isolated system is there, then here three particles are there, A, B, C. So the charge on A is 4 coulombs, charge on B is 3 coulombs, and charge on C is minus 2 coulombs. Now, I made some modifications in this body and I obtained the same system A, B, C. So, due to the modifications what I made in this body, I observe the charge on body A is 3 coulombs, charge on body B is minus 1 coulomb, and what is the charge on C? Now, we want to calculate the charge on C. So how can we calculate that? We know that for an isolated system, the charge is constant. Means 4 coulombs plus 3 coulombs minus 2 coulombs equals to 3 coulombs minus 1 coulomb plus x. Means here 7 minus 2 equals to 3 minus 1 means 2 plus x. It is 5 equals to 2 plus x. Then x equals to how much? 3 coulombs. Means what modifications we made, but the total charge remains constant. This is known as conservation of charge. Means the charge in an isolated system is conserved, means constant. Okay. So these are the important properties of charge. And one more is the charge is invariant. Charge is invariant means if the charge is at rest or the charge is in motion, whatever may be the position, whatever may be the situation or condition of the charge, the total charge is constant. Means unlike mass, if the mass is at rest or mass is moving comparable velocity of light, then we know that the mass is changes. So we have to attempt that in special theory of relativity. The mass of the body is rest mass of the body upon 1 minus v square by c square. Means from this expression we know that the mass of the body is changes in motion, but here the charge is invariant, means either it is rest or it is in motion. The total charge is constant. There is no change in charge. Okay, due to its position. That's why the charge is invariant. Now, one more property is the interaction between two charges is independent of presence or absence of another charge. The interaction between two charges is independent of presence or absence of another charge. So, in order to understand that, here we have one charge Q1 and one charge Q2. The interaction between these two charges, now I keep here one more charge Q3. Means whatever may be the force between these two charges is independent of the presence or absence of that third charge. Okay. This is also one of the property of the charge, that is the interaction between two charges is independent of presence or absence of the another charge. Okay. So these are the properties of charges. Once again, we will recapitulate. What is first one? Charges are at two types. One is positive charge, negative charge. Like charges repel each other, unlike charges attract each other. And we already see what is the charge of electron, mass of electron, and mass of proton. And the next one is charge is quantized, equals to plus or minus NE. If you want to transfer charge, then it is possible only in the integral multiple of electron. And one more is the smallest possible charge is charge of electron. And next one, the charge is conserved, means for an isolated system the total charge remains constant. And next, the charge is invariant, means the magnitude of charge does not depend on the condition, means either it is at rest or it is in motion. So there is no change in the magnitude of charge. So that's why the charge is invariant. Okay. And what is the next one? The interaction between two charges is independent of the presence or absence of the another charge. So these are the important properties regarding charge. And now the next concept is Coulomb's inverse square law. So what is Coulomb's inverse square law means? If we can take two charges Q1 and Q2, if these two are like charges, we know that there is repulsion between these two charges. If these two are unlike charges, we know that attraction exists between these two charges. Now, these two charges are kept in a medium by a distance of r meters. Okay. Now, what is Coulomb's inverse square law means? It states that the force of attraction or repulsion between these two charges, force of attraction or repulsion between these two charges is directly proportional to the magnitude of product of the two charges and is inversely proportional to the square of the distance between them. So that is the statement of what? Coulomb's inverse square law. Okay. If you can take two charges Q1, Q2 are separating at a distance r, then the force of attraction or repulsion between the two charges is directly proportional to the magnitude of the product of the two charges and is inversely proportional to the square of the distance between them. So here, for simplicity, we can take these two are what type of charges? Positive charges. Now, the force acting on Q2 due to Q1, it should be taken as F21, means force on 2 due to 1. So it is the second charge, it is the first charge. Now force on 2 due to 1 is F21, and here force on 1 due to 2 is F12. So here the since these two are like charges, the force on this charge is in this direction, means both are repel each other. Okay. And the force on Q1 due to Q2 is in this direction. So both are repel each other. Now the magnitudes are same. We can write it as F12. The magnitude of F12 equals to magnitude of F21. Both are same. So here, by using these two, F is directly proportional to Q1, Q2 by R square. If we can remove that proportionality symbol, then we can take a constant. It can be taken as K. Then K into Q1, Q2 by R square, where this K is known as proportionality constant. And experimentally, the value of K is obtained 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught. This is the value of K. And here it is experimentally found that the value of 1 by 4 pi epsilon naught is, accurately it is 8.99 into 10 to the power of 9. Okay, but whenever we solving problems, it should be taken as 9 into 10 to the power of 9 Newton meter square per coulomb square. This is the value of K. So K means 1 by 4 pi epsilon naught, and the value of 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 Newton meter square per coulomb square. So what is this epsilon naught here? So epsilon naught means it is the permittivity of free space. It is the permittivity of free space, and the value of epsilon naught is 8.825 into 10 to the power of minus 12 coulomb square per Newton meter square. Okay, this is about Coulomb's inverse square law. And one more point is, it is only applicable for point charges. It does not hold good for extended bodies. Okay, it is only holds good for point charges. Okay, so what is the final expression for force of attraction or repulsion between the two bodies? That is F21 is equals to F12 equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. We will come to this point. Here the magnitude of the two forces are equal and the directions are opposite. Directions are opposite and the force is acting along the line joining the two charges. Force is acting along the line joining the two charges. So that type of force is known as central force. That's why the electrostatic force is a central force. Okay, since the force is acting along the line joining the two charges, that's why electrostatic force is a central force. And this electrostatic force is action reaction pair. So what is action reaction pair? The forces are acting on two different bodies. Forces are acting on two different bodies means here charges. Forces are acting on two different charges. Now we have to attempt a few problems on Coulomb's inverse square law. So what is the formula? Force F equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now we have an equilateral triangle of side A and we keep three similar charges at the three vertices of an equilateral triangle of side A. Then find out the force on any one charge due to the remaining two. What we have to find? The force of electrostatic force on any one charge due to the remaining two charges. Okay. For example, if we can take this charge is 1 and this charge is 2 and this charge is 3. Now, what is the question? Find out the force on 3. Find out the force on charge 3 due to the remaining 2. Due to the remaining two charges. So now we can take force on 3 due to 1. It is in this direction. Okay. It is force on 3 due to 1. And next force on 3 due to 2 is in this direction. It is force on 3 due to 2. So all these sides are equal since it is an equilateral triangle. Now we have to calculate force on 3 due to 1. It is, we can take this as K. Then K into similar charges Q into Q, Q square by A square. So F31 is how much? KQ square by A square. Now we have to calculate force on 3 due to 2. So it is also equals to how much? KQ square by A square. Because all the three charges are similar and it is a equilateral triangle. Now it is equation number 2. Okay. So it is the one force and this is the another force. Since it is an equilateral triangle, the angle is 60 degrees. So that's why the resultant force is in this direction. Since these two are having equal magnitude, we can write it as for simple calculation, we can take this is F as well as this is also F. Then the resultant force or net force can be written as root over F square plus 2F square cos 60. Then how much? We obtained F square plus F square 2F square into, we know that what is the value of cos 60 degrees? 1 by 2. 2 gets cancelled. What is remains here? F square plus F square plus F square means it is a root over 3F square. Means it is root 3 into F. We know that root 3 into F. What is the value of F? AQ square by A square. So this is the net force on any one charge due to the remaining two. Similarly, we have to calculate the net force on any one charge of square. For example, it is one square of side A. Now we keep similar charges at each vertex. Now it should be 1, 2, 3, 4. Okay. Find net force on charge 4 due to remaining 3 charges. So the force on 4 due to 3 is in this direction. Since these two are similar charges, repulsion is there. So it is the direction of force on 4 due to 3. And in this direction, the force in this direction, force on 4 due to 1x and force on 4 due to 2x. Okay. Now we have to calculate these three forces and we can add these three vectorially. Okay. To obtain the net force or resultant force. Now, what is the magnitude of force acting on 4 due to 1? It is K into Q square by A square. And the next force acting on 4 due to 3, it is also KQ square by A square. So we know that these two forces are acting perpendicular to each other. Okay. So the resultant can bisect these two forces. That's why it should be taken as F dash, where F dash is the net force or it is a resultant due to force on 4 due to 1 and force on 4 due to 3. It should be taken as F dash. So what is that F dash? For example, it is F and it is F. So we can write it as F square plus F square. So it is simply root 2 F. Okay. Now here it is A, here it is A. Then we obtain this side as root 2A. Now what is the force on 4 due to 2? It can be taken as F 4 2 is equals to K into Q square by R square means root 2A whole square. That means it is KQ square by 2A square. Here the resultant of these two is root 2 into KQ square by A square. Now since these two are along the same direction, we can add these two forces directly. So the net force on 4 is F dash plus force on 4 due to 2. What is F dash? Root 2 into KQ square by A square plus here KQ square by 2A square. And if we can take common KQ square by A square, then what is remains here? Root 2 plus 1 by 2. So that is the answer.